Thank you for joining to our seminar. I'm Takashi Sakakibara. I'm a CFD engineer, and today I will introduce you the function of the fluid dynamic simulation of Ansys. Okay, this is the agenda of this webinar. At first, I will introduce ourselves and Ansys Inc. And after that, I will explain the function of the fluid dynamic simulation. And as I told you, there's a Q&A session, so please feel free to ask me on the chat box. Okay, this is about our company. The headquarters of our company is located in Tokyo, Japan. And our company established over 30 years ago. And we have several overseas branches. And the Cybernetics System Malaysia is also one of the branches in Southeast Asia. And we have not only sales subsidiaries, but also develop subsidiaries all over the world. So this is about our solutions. We mainly provide the CAE-related service to the customers. And Ansys is one of our solutions we provide. And furthermore, we provide AR, VR solution and big data solution, IoT data twin solution, and IT solutions, and engineering service. As an engineering service, we provide several kinds of the training, consulting service, and sometimes we do the simulation for you by ourselves. Okay, let's move to the Ansys. So Ansys is the name of the simulation tool. And Ansys has various types of the simulation, like fluid dynamics, electromagnetics, structural analysis, and so on. And also the additional good strength point is the function of the connecting each solutions. For example, structural fluid coupling and electromagnetic fluid coupling and electromagnetic structural coupling and so on. And also Ansys is used all over the world and used in a lot of the industries like automotive, electronics, aerospace, and energy, medical, and construction industries. Okay, this is about Ansys Inc. So Ansys Inc.'s headquarters is in the US, and it is founded in 1970. And Ansys Inc. Continuously expands their solutions, and now they are the largest simulation software vendor. And their mission is pervasive simulation. And this means they provide any kind of simulation tools for any kind of engineers. Okay, so I'll show you some of the solution of Ansys. For example, Ansys has mechanical solution functions and thermal fluid and electromagnetic solutions. So in this seminar, I'll focus on the thermal fluid solutions. Okay, let's move to the next session. So in this session, I will explain what is the CFD. So CFD stands for the computational fluid dynamics. It's a fluid dynamic solution. In this session, I'll share some examples of the CFD. So this is an example of the flow pattern inside a cafe. Okay. So, like this example, you can understand the situation of the flow and the temperature visually. Okay? And you can know where is the highest temperature point and where is the lowest temperature point. Okay, this is another example of the fluid dynamic simulations. This is a flow pattern around the summit of the mountain, around the mountains. So first, I got the geometry data from some government institute, and I made this simulation model. So by this simulation model, we can know where is the strong wind position and the situation of the turbulence. Okay, and like these examples, CFD can provide you some information about flow. For example, velocity between buildings, like this example, and temperature inside a cafe, and the gas fraction inside the pipes, and performance of turbo machineries, and tank movement considering liquid movement. So this is some example of the fluid structural coupling. And you can know the sound considering with the flow. This example also one of the coupling simulation. It is fluid and acoustic coupling simulation. So, like this example, you can get several outputs from the CFD analysis. Okay, from this slide, I'll show you some example of each industries. So this is the example of the aerospace industry. So like these examples, so you can know the flow pattern around the airplane, and also you can know the flow pattern inside the airplane like this. Okay, so this is an example of the automotive industry. So like these examples, you can know the flow pattern around the F1 car and the temperature inside bonnet. And you can check the flow pattern and the temperature inside the internal combustion engine. And you can use the CFD for the thermal control for this kind of the battery. Okay. Okay. This is an example of for the healthcare industries. So you can simulate the devices for pneumonia, okay, and incubator and the blood flow. This is a blood flow analysis result. Blood flow inside the blood vessel. Okay. Okay, this is an example of the energy industry. So you can simulate the gas turbine, and windmill, and some devices of some parts of the nuclear power plant. Okay. This is an example with the manufacturing industry. So you can simulate the burner. This is an example of the burner. And mixing tank. This one is a mixing tank. And bulb. And this is a cyclone separators example. Okay. Okay. So this is an example of the high-tech industry. In other words, it's the electrical devices simulations. So like this one is a hard disk simulation, and CPU and RC package. So in this industries, basically the customer checks the temperature of each part of devices. Okay. This is an example of the consumer product and the construction industry examples. So we can note the flow pattern inside the room like this, and flow pattern around the buildings. And this is one of the famous example of the Dyson. This is a customer's example. So Dyson is Ansys customer, and Dyson uses Ansys Fluent, and they developed the braidless fan by using the Ansys Fluent. Okay, in the next session, I'll explain more detail about the CFD software of Ansys, named Ansys Fluent. This is about the license of the Ansys CFD. So there are two types of the license for CFD. The one is the Ansys CFD Premium, and the other is Ansys CFD Enterprise. So if you don't have any special needs for polymer and resin flow and IC analysis for airplane, so in this case, I mainly recommend you to use this license, Ansys CFD Premium. Okay. So and the main product of Ansys CFD is Ansys Fluent. So you can use Ansys Fluent by this license, Ansys CFD Premium. So this is the outline of the Ansys Fluent. So Ansys Fluent is a high-end general-purpose CFD software. And the Ansys Fluent can support not only normal thermal fluid analysis, but also more advanced phenomena like multiphase flow, reaction, combustion, rotating machinery, heat radiation, and so on. And also, Ansys Fluent provides a lot of options for each functions. So you can simulate the phenomena even if it is so complicated. And Ansys Fluent is also used for academic research needs, because Ansys Fluent has a wide and flexible customization functions. Okay, now I start to explain about each of the functions briefly. Okay, this is an example of the natural convection in the current, this one. So in this case, I think it's better to consider the influence of the thermal radiation. And thermal radiation influences the result of the temperature profile. I think that especially in the case of the normal convection and the high temperature phenomena, like combustion, you have to consider the influence of the thermal radiation. And this one is about a CFD result around the landing gear. So by using the turbulence model, you can predict the risk of noise induced by the flow. Okay, so So in the case of the turbulence, so Ansys Fluent has a lot of the options of the Fluent, turbulence model. So this example is for the backstep flow, and but we use different type of the turbulence model for this phenomenon. So this left figure shows the result of the using a typical turbulence model. So it is used for getting the average result of the flow. So you can simply get the flow result by using the typical turbulence model. Okay, and right figure shows the result of using high-end turbulence model. So in the case of the high-end turbulence model, the cost of the simulation is relatively high, but you can check the fraction of the flow and detailed structure of the turbulence. So like this, you can select the suitable turbulence model that is suited for your demand. Okay. And also, Ansys Fluent has a special turbulence model that is suitable for the specific phenomenon, like supersonic flow. This is an example of the supersonic flow. Okay, this is about merge component flow and the merge phase flow. So this one is a merge component. So merge component flow means we consider different type of gases. And in this example, I consider the change of the mass fraction of oxygen and nitrogen. Okay? This contour shows the mass fraction of the oxygen. So red area is a high mass fraction of the oxygen, and the blue area is a low mass fraction of the oxygen. So this one is a merge phase flow. So this example, if we use the function of the merge phase flow, we can consider the different type of phases like gas, liquid, and solid. So in this example, we consider the water and air at the same time. And as a result, we can get the result of the free surface. Where is the free surface and the shape of the free surface, we can know. This one is the free surface. Okay. So, and there are a lot of the different types of the multi-phase flow model. So, okay. This is an example of the droplet. So I can set I set the air and the water, and we can take the shape of the droplet like this. Okay. And this one is particle flow simulation, and we set air and the particle solid. So we can know how the particle moved by the influence of the airflow. Okay. And this one is an example of the fluidized bed. So in this example, this area is the sun, and this bubble and this area is the air. So we set the solid and air to express the fluidized bed. Okay. And also you can consider the phase change like water boiling. So in this example, we set water and steam. Okay. Okay, it's a next example. This is an example of the combustion and the reaction. So this example shows the results of the combustion simulation for burner. So by using this function, you can know the change of the mass fraction of each gas component and the change of the temperature by combustion. So I'm not sure, but I think that this is some gas species mass fraction or temperature. Okay, probably temperature. Okay, and this one is an example of the CVD. CVD stands for the chemical vapor deposition. So this is the example for the semiconductor industries. So like this example, Ansys Fluent also provide a function. Also provide the function of the surface reaction. Okay. And Ansys Fluent also has the function of the moving mesh. So for example, this is the example of the storing tank. So red and blue regions show the different type of the liquid. And there's a braid and baffles. Okay. So mixing conditions depend on the position of the braid and the baffle and the rotating speed of these braids. So as a result, we can know the situation of how the liquid, this liquid is mixing. Okay, so this example is example of the turbo machinery. So there's a static braid and a rotating braid. So like this example, you can know the velocity and the pressure distribution between these braids. Okay. Okay, this is another example of using the mesh deformation function. This is about the flow around the floating ping pong. So depending on the movement of the ping pong, the mesh around the ping pong changes automatically by this. So mesh is moving. Okay. Okay, so next one is optimization and power computing. So Ansys Fluent itself has the function of the shape optimization. We call it adjoint solver. So adjoint solver is a kind of the sensitivity analysis tool. For example, if the objective is to maximize the downforce, the adjoint solver shows how to change the shape of the object to maximize the downforce. So this is a result of the adjoint solver, and there's a lot of the vector, and the yellow vector shows recommended direction of shape change to increase the downforce. So that means that if you change this area to the upper side, you can get more. You can increase the downforce. Okay, and this graph shows the effectivity of the power computing. By using several cores at the same time, you can improve the simulation speed. And you can use the power computing function more effectively in case that the model is so complicated and you need a high quality result. Okay, this is the result of the benchmark test of power computing. By increasing the number of cores, you can decrease calculation time. So like this. Okay, in the next session, I will introduce you the workflow of Ansys Fluent. Okay, so CFD analysis start from CAD data. Of course, you can use your original CAD data for the simulation. But if you don't have any CAD system, you can use Ansys Spectrum for making geometry data. So, and after you prepare for the CAD data, you have to make the mesh. So meshing process is very important because mesh decides the simulation cost, quality, and the stability of calculation. And after you prepare the mesh, you move to the solver setting, and you start the calculation. So in the point of the calculation, depending on the number of mesh or your setting, it takes calculation takes several hours or days. But in that case, as I told you, you can use the parallel computing function. Okay? And after you get the result, you can visualize the result by using the post processor. In this session, I explain about the modeling and the meshing and the post-processing tools. Okay, so this is about the modeling tool. The product name is Ansys Spectrum. So this is like a normal CAD system, but this product focuses on the preparation for simulation. So the strength of this product, of course, is easy to use. And this product have a lot of functions for simulation preparation, like simplification and repairing the CAD data. And also, space frame has a function of the import and export geometry data in several CAD formats like this. So this is one of the functions that is useful for the CFD analysis. If you want to get the internal region of some geometry, you can use the volume extraction function. And if you want to get the outer region from some geometry, around some geometry, you can use the enclosure function. Okay. Okay, so next is about meshing. So as I told you, so meshing is very important for accuracy, and calculation time. So you have to select a good meshing tool so that you can make a good and high quality mesh in a short time. So Ansys has several meshing tools, but I recommend you to use the Ansys Fluent workflow. So Ansys Fluent meshing itself is a high-end meshing tool. But if you use the function of the workflow of the Ansys meshing, you can get a high-quality mesh easily in a short time. So this is about the function of the workflow of the Ansys Fluent meshing. So you can select one of the workflow from several choices from in here. Okay. So after that, all you have to do is just follow the navigation of this workflow. Okay, so you step by step you set the meshing setting. Okay, so by using this workflow, you can get several types of the volume mesh, like tetra, polyhedral, polyhexagonal. And you can also add a boundary layer mesh like this. So which is needed for good quality result of the CFD. And this is a picture of the polyhexagonal. Okay, this is a hexamesh. Okay, this is a polyhedral mesh. Okay. This is a kind of the hybrid mesh. Okay, and after finishing the meshing process, you can simply move to the solution mode. Just put this button. So today, I just focus on the Fluent meshing workflow, but Ansys provides several options of the meshing. So I think it's depend on the customer's needs. Which tool is suitable. But basically, your first choice would be workbench meshing, this one, or Fluent meshing. So I think if you already have the experience of using Ansys workbench meshing for other kind of the simulation, like mechanical simulation. So in this case, I think Ansys workbench meshing would be the good choice for you. Okay, this is about the post-processing tools. So same as the meshing tool, there are also several choices of post-processing tools. There are three post-processing tools like Ansys Fluent Post, Ansys CFD Post, and Ansys ANSYS. Okay. So I think the first choice is Ansys Fluent Post. So you can easily use this post processor on the Fluent GUI. So this is useful to check the result easily and simply. And I think the Ansys CFD Post is a more advanced CFD post processor. So I think you can use this Ansys Post as a Ansys Post. Ansys CFD Post, and in the case of you want to analyze more detail about the result. And Ansys ANSYS is a general purpose post processor, and I think that this is the most advanced post processing tool in Ansys. So you can use this post processor if you need a more advanced post processing function, or if you want to post process for the non-Ansys CA tool. Okay. Okay. Now I'll start to demonstrate how to use Ansys Fluent. I start from the importing a geometry file, and I finally check the results by using the Ansys CFD Post. Okay.
Okay, now start the demonstration of Ansys Fluent. First, this is the GUI of the Ansys Fluent meshing. So this is the meshing mode. So first, I import the geometry file, and I try to make the mesh before the setting of the solver. So first of all, can select several workflow types, but this time I will select the watertight geometry. This workflow type is for the high quality calculator. Okay. And after I select the watertight geometry, there will be the each of the steps of the workflow. So now I try to check each of the steps one by one. So first, I import the geometry. So I click the import geometry, and I select the file name. And after I successfully import the calculator, I can change the shape of the geometry like this. Okay. So in this case, I imported the manifold calculator, and this is only the fluid region, and there's a four inlet. The flow coming in these four parts. So I already named these four parts like inlet 1, inlet 2, inlet 3, and inlet 4. And also I already set up the name for this part. This part I named outlet. Okay. So other finishes is registered as wall. Okay. And first, I have to set up the local mesh size. But almost every setting you can use the default setting. So in this case, I just put the update button, and this square shows the minimum size, and this is the minimum size, and it is the maximum size. So automatically, Ansys Fluent meshing sets the minimum size and maximum size from the geometry file. And I click the button of the Create Surface Mesh. And first, the Ansys Fluent mesh try to make the surface mesh of this geometry. Okay, this is the surface mesh. So like this, the fluent meshing automatically makes the surface mesh. Okay, and after that, I just use the default setting. So, for example, I set the information of the geometry. As I told you, this is just the fluid region. So I have set the geometry consists of only fluid region on no void. So I click this one and click describe geometry. And I can change the setting of the boundary condition. So also, as I told you, we've already set the name of the inlet 1 and inlet 4 and outlet, and automatically the Ansys Fluent sets the boundary type from the name of the boundary. Okay? So if there's no need to change, I have to just push update boundary button. Okay, and automatically I can add the layer mesh. Okay. So layer mesh is important for the fluid analysis. So I push the add boundary layer. Okay, so now all of the settings needed for making the body mesh is completed. So I just push create body mesh button. So if you want, you can change the shape of the body mesh like hexagon or polyhexagon, polyhedral. But now I just select the default setting for his role, and I push the create volume mesh button. Okay, so please wait a minute. Okay, now I can get the volume mesh like this. Okay, so I can check the mesh shape of the inside. So you can change the cross section by using this slidable. Okay. So you can check. You can know there's the boundary layer on the wall. Okay. Okay. So like this, you can get the mesh shape very easily. Okay. After you finish the meshing operation, next step is the setting of the solver. So you just push this button, switch to solution button. Okay, this is the solution mode, and from now I try to set the setting needed for the starting the solver. So first, I check the turbulence model. So as I told you, Ansys Fluent prepared a lot of the model and also the turbulence model. You can select the turbulence model from the lot of options. But this time, I select the very basic turbulence model. Okay. And okay, so you can select the material property. So Fluent has a database of the material property. So you can set several material properties. But now I just use the default setting of the gear. Okay. And the next step is I have to set up the boundary condition. So there's four index conditions. So for example, I try to set up the index velocity like 1 meter per second. Okay. So, and in the case of the other index, it is the same condition as the index 1. So I just copy the index 1 to the index 2 and index 3, index 4. It's the easiest way to set up the same setting. Okay. And let's see the outlet. The outlet is already set up. I think the default setting is already good. So there's nothing needed to change the setting of the outlet. Okay. Next step is to set up the initial condition. So initial condition is needed to set up before the start the simulation. But you just needed to push this button, initialize button. Okay. So after finish all of the settings, finally you set the run calculation button and set up the number of the iteration. So this time I set 100 and push the calculate button. So after all of the residuals of each equation is getting down below some criteria, the calculation is automatically stopped. Okay, finished. So as I told you, you can select the post-processor from the several options. And you can use this is a Fluent Post. So you can check the result like this. This is a Fluent Post. So Fluent Post is easy to use and easy to access from the Fluent UI. But if you want to do the more advanced post-processing, you can also use the CFD post. So if you want to use the CFD post, you just push this button, export to CFD post. Okay. So just push the right button. Let's wait a minute. Okay, first I set up the coloring of these walls. So I think this kind of transparent wall is very easy to understand the situation of the inside. So first I set up the streamline of each of the index. Okay, so you can check the flow by using the streamline. And you can set the animation like this. So you can also understand the situation of the flow by using this kind of animation. Okay. Okay. So and you can check the velocity and distribution, velocity profile, or vector. So first I set up the plane. Sorry, wait a minute. Okay, I set up the plane and check the velocity profile on the display. Okay, you can check the this is first. So you can check the velocity. And also you can check the flow direction by using the vector. So you can check the vector like this. Okay, so you can check this area. Row is very first, and you can check this area. There's the air is floating like this. So there's 80. So and also, so you can check this area can be there is 80. So you can select normalize vector length. Okay. So like this, you can understand there's a possibility of the backflow. Here's also there's a backflow. So like this, you can check you can get the several information of the flow by using the Ansys Fluent. Okay.
Okay. Now, I'll explain about our service. So, of course, we provide the simulation software, but also we provide a CA-related service like operation support, planning, education, and consultation. I think there's a two-stage of our service. It's before using simulation software and after you study simulation. And I think that at the first stage, we provide a startup support service. So this service is needed, especially for the people who don't have enough experience of simulation. Sometimes we prepare the sample data for the customer and provide the technical training. And at the second stage, we provide a daily technical support service. And sometimes we provide the engineering service when you don't have enough resource for some simulation. So that means we can do the simulation by ourselves for the customer. Okay, now I want to start the Q&A session. So I will reply for your comment and questions. So, okay.